Thanks, guys. I'm really excited to be a part of this. And it was great to hear Ellen's conversation right before this, because a lot of the things that she had to say are a lot of what we had to say. And I've listened to some of these sessions today. It's been really good to hear a lot of alignment and consistency in where we're going with this industry. So I'm Jill Cohen. I'm the global commercial leader for Dsm Additive Manufacturing. I just showed the interesting video a second ago, and I think if you look at it, you could say, well, that sounds like a really interesting application, and I'm anxious to hear more about the details about it, and I'm looking forward to sharing it with you. I would say at the same time, I'm going to challenge all of you to think a little bit broader and think about this as not just an application, but something that triggers in your mind what is possible if we work together to innovate and collaborate together. So I'm going to talk about sustainable 3D printed footbridges. But before that, I think I'll take you back a second to how we got here. So let me give you a little bit of background on DSM Additive Manufacturing. So the company has a long legacy in additive manufacturing. We've been a pioneer in this industry for many years. And as I listen to people present today, I hear folks talking about how long they've been in the industry, and they talk 5, 10 years. DSM has been in the industry over 20 years, almost 30 years. If you look at the start of our involvement was in our acquisition of the Somos business, which many people, if you know stereolithography, if you know additive manufacturing, you know Somos. And we acquired that in 1999 from DuPont. So the legacy of our strong position in photocurable materials and SLA specifically goes back a very long way. But in addition to that, DSM is a material science company and has had a long history in that as well. So our legacy in material science led us fairly quickly to additive. And in 2010, our business was looking at projects in 3D printing around how the materials we use can be processed in different ways. And even beyond that, our engineering materials business, which are focused on polymer technologies, began in 2016, creating even commercial offerings at that time in filaments and in pellets that were commercial. So our legacy has been a strong foundation of who we are. But in 2017, our company looked at all these technologies and capabilities and said, this looks like an opportunity we can pull together. So in 2018, we formed DSM Additive Manufacturing. And what it was really about was building on the strengths of both the photopolymers technology, but also our extrusion-based capabilities, as well as powder printing, and really forming this business. So we started that in 2018. And since then, our focus has really been around innovation in the space and expansion of our business. So if you think about the innovation side, in the last 18 months, we've launched 11 new products, new to additive in general, and really had an acceleration in the last 6 months of those. You can see across many of the different spaces in FFF and FGF, in powder bed fusion, SLA, and DLP. DSM has been involved in all those areas. In addition, in terms of expansion, we've signed over 30 partnerships, done venturing work, and we even acquired Clariant's assets last year in the filament space. And I put "and more." Many of you may know that as we continue to expand our business, we announced in October that Covestro will be acquiring our business, and we will have even further potential to grow with the material science company and expertise of a Covestro. So all of this means that we've come a long way in terms of our legacy, but where we are today is really a focus on how do we move forward in additive. And what we say is, let's manufacture tomorrow. So what does that mean? What does let's manufacture mean? It really is our ambition. It's our ambition for thinking about this industry in a different way. And our goal and our vision is to truly unlock the full potential of additive manufacturing. Ellen was talking about it, and others have talked about the potential that, you know, we are doing more and more every day with additive, but how can we truly unlock the potential to move beyond prototyping, to move beyond small scale into full scale sustainable production and improving people's living? So when we say let's manufacture tomorrow, we don't mean just us, we mean let's do that together. And so we see ourselves as the leading partner for enabling some of this through customers' printing applications, through the material side for sure, but also for application knowledge and how we connect to our partners. So the way that we approach it is a way that I think is critical, and I'd love that all of us would be thinking about this together. Our operating model is thinking about how we enable this in 3 unique ways. Number one, we are firm believers that it starts with the application. If we're going to enable manufacturing, we have to understand what's required. There won't be one size fits all. There will be multiple options to suit that application need. And so from our perspective, the applications experience that we have helps bring about development of solutions that combine design and printing and material all together. The second, as I said, is we can't do this alone, and neither can any of us. And so finding the ability to build an ecosystem of partners that can solve these application needs is going to be critical. And then the last element is innovative business solutions. The fact that the way that manufacturing works, traditional manufacturing works, and the business models used to make them successful are likely not going to help us accelerate additive. The economics and the models that we need to get there are going to require us all to be flexible in that. So when we approach the market, we approach these applications, we look for ways to be innovative and collaborative together. In addition to that, we bring the materials that we feel are necessary for solving these application needs. So our main goal is really to find the best solution for the application. It's not one material or the other. It's a combination of design and software and materials. So that's why we're working on a portfolio of technologies, of materials across all technologies, starting from the background in our history in the SLA space and thermosets, and building our capability as we've launched new products in DLP and continue to evolve there. At the same time, from our thermoplastic experience, starting with our experience in filaments and launching new products in powders and in pellets as well. In addition, to do this requires a strong platform that enables us to grow, move, and innovate quickly across different technologies. And so that's something we've established as well. And then last but not least, one of the most important things for us across all this, and I've been excited to hear a lot of folks talk about this today, is sustainability. Any of us that are in the polymer space or in any manufacturing space need to understand the impact that we're making on the world. And so it's our vision and goal to be a circular solution provider for all AM customer needs. And that's not just from an environmental footprint, you know, as we look at how our operations affect the environment, we continue to challenge ourselves to be sourced even more from 100% renewable energy sources and continue to grow there, but also in our products, looking at expanding our use of bio-based and renewable feedstocks, and then also in circularity. I mean, especially as we get more into digital options and digital initiatives, the ability for circularity becomes critical. So all of this comes to bear, and in the example that we saw in the video of circular bridges. And so this is a good example of an application which brings all those pieces, the unique application need that's a challenge that requires partnership and collaboration with an ecosystem of partners, and then also brings a sustainable option. So let me take you through this project in more detail. The first question is, okay, why circular bridges? Well, I think it's pretty clear, and all of us have talked about the need for sustainability. I mean, right now, it's very clear that the demand that we have on the ecosystem, the Earth's ecosystem, requires that we either reduce the demand or grow the Earth. So I think most of us are very clear, and around the world, more and more initiatives are coming to help focus the world on reducing that demand. The European Union specifically has created a focus on this with their Green Deal and the goal to be carbon neutral by 2050. But in addition to that, if you dig down into the drivers and what things are impacting our environment and our demand, infrastructure is significant impact. The World Bank quotes that 70% of greenhouse gas emissions come from infrastructure, construction, and operations. And so when you look at the opportunity for an application that is a challenge that can be developed using 3D printing technologies that can solve some of these needs, circular bridges was one that became a demand that came our way. And so how do you approach a project like this, or any project in additive? The first thing is finding an ecosystem that works. So we teamed up to win in this project with 2 other players. And the first player, Royal Haskoning. Royal Haskoning is an international engineering and project management firm. They have over 100 years of construction and infrastructure experience, and they have a big focus on innovation and sustainability, making them a very key partner in this project. In addition, we partnered with a company called Seed. Seed is a leading innovator and manufacturer in large size 3D printing. And so given that we're talking a bridge, it was a significant challenge. They became a very key partner for us in this initiative. So a bridge, how do we approach this project, and how do we do this together? I mean, the first step is design, and that's the first step in any of these, as you know, is designing a bridge. And so how do you design a bridge? I mean, the key around designing a bridge is understanding and designing the force flow from the bridge to the ground. And here's a typical bridge where you can see how the design was made in order to manage that. So you start with the techniques that are available today. But the second thing is you move into a process of a design which balances what you design with the material you're going to use and the process that you need to use. And so one of the keys for us in additive, as everyone knows, is the automated process. So today, using machine intelligence and putting these factors all together, we can get a process called generative design, and that enables the software to create designs based on all the parameters that we need. And generative design was key in this project. You can think about the ways in which design for manufacture has revolutionized things that we need to create. I mean, there's some examples on this chart that are unique, but these are the kinds of things that design for manufacture can enable. And so things that might not have been possible before with design for manufacture can be possible. And so we took an approach to use this methodology in designing the bridge. So working with our partners, the first step was really trying to explore the rules for generating large structural engineering type parts with additive manufacturing. And so, as you can see, this simulation started with a big piece of material to develop the design. And as it continued to iterate, it started removing material to try to get the reductions that we needed in the size and the weight of the part. And it also enabled us to look at these things in terms of options for printing. However, the first initial part did not have factors in for printing. So it just said, okay, here's a part you could print. It didn't put restrictions or characteristics of material or things within it. And that's what we needed to look at together. We needed to figure out, okay, based on this design and based on these options, what limitations are they? And how can we continue to iterate in generative design to get a solution that would work? ultimately, we came up with a number of different options. And so coming out of that process, there were, all these different options to consider. And the key was, how do we work together to select the optimal one? We used multiple levels of collaboration with our partners, but also using external efforts, like we had an I Am Tomorrow challenge, which seek to look at this and optimize the design. In the end, we ended up selecting the design, and we moved forward with the project based on that design. So a lot of effort at first in the design, going beyond what we had anticipated, but using generative design to get there. Then it was on to the material. And so the material selected for this was DSM's Arnite. This material is a fully circular material. It has various applications and end-of-life issues that are very positive and can be explored with 3D printing. It's in granular form, and it provides this application with a shorter development cycle, the ability that was fit for the performance that we needed in this application. It had a low carbon footprint and also gave the cost and lifetime goals that we needed. So with the design in hand and then the material selected, we said, okay, let's just print it, and started moving forward to print. So as we did, the key was, okay, how are we going to process this? And so if you look, this was some of the initial printing where some of the structures we had designed needed to be created. And you can see there were some implications based on the printing, not only for the printing, but also for the performance of the part. And so, yes, we printed the part, but there were some issues and some structural flaws that we had to address. So using design techniques, using slicing tools, using collaboration with our partners, it raised this challenge for printing. How are we going to solve this? And that collaboration ended up getting us a new path, the new tooling path that enabled us to not only minimize the issue, but also strengthen the part and the structural integrity of the part. So in the end, this was what we were able to do and begin to print this part. You can see after the iterations, after the design and the work together on this, you can see that we have very clean and neat internal structures, and it really enabled us to get the part that we needed to move to the next level of this project. But then it came about performance. Okay, we've got the design, we've got the material, we've got the part printed. Now, what about the performance? And this is where our partnership came in, and really our partnership with Royal Haskoning became really key as we looked at how will this this bridge react. And so we put sensors in the bridge and had folks walk across it and measured the performance to see how the material and the structure would behave. And it ended up creating more and more variables that we were able to look at together to optimize the design. So ultimately, where did the project lead? So it started early in 2019. The first attempt, we printed a 1 meter bridge, and that was based on the initial optimized design. Based on the performance parameters, we printed 1 meter. And some people who were very brave got up and stood on it and found that it was successful. We learned and optimized from there in mid-2019, moved to a 1.5 meter bridge, and then a 2 meter bridge. And really the focus was around using predictive modeling and simulation and various other things to kind of optimize the design, really focusing on the internal fill and the fill structures, especially to make sure that it was going to have the performance we needed. At the end of 2019 at FormNext, for those of you who might have been there, we had a 4 meter bridge at FormNext, and we're successful in printing that. And the goal is now going bigger and moving that to the next stage. So if you look at this whole project, you can see all of the elements that went into play in working with all the partners, trying to develop all the options and opportunities to make this application come real. And it's true for any application. If you think about also in this case, the goal of this project was taking virgin material and enabling it to be 3D printed. But one of the next steps in this is how do you make it also recyclable and ultimately make it so that the bridge itself can become recyclable or reused for other purposes. You could envision the bridge at some point in time when it's taken out of service being used for something else. And that's where we're headed. It makes the possibilities really endless. If you look at the opportunity for the material here to go into this object and then to use digital tools to be able to track and monitor. I mean, you can see predictive maintenance. You can see the ability to create digital twins that monitor performance over time, not just for bridges, but for any kind of application as you go forward. So in the end, this is the rendering of the bridge that was shown in the video. So in Rotterdam, we will be putting a bridge in, a pedestrian bridge, and that bridge will be, was supposed to be installed at the end of 2020, but due to COVID has been delayed. So we're very excited. It should be putting in March or April timeframe is the plan. And the goal is to create full-size footbridges, but not really stop there. We can do things in terms of bike bridges or construction where we're creating permanent structures or bridge decks or boat ramps. There's lots of potential that can come from this application, and it just started from thinking together about what might be possible. I would say that the other piece of this is that this kind of collaboration is what we look forward to, and not just in this space and not just with this type of technology. Tomorrow, my colleague Gabby Janssen is going to be participating with two other partners, Twicket and Ultimaker, in a session here about the value of mass customization in a completely different field, that field of personalized orthotics and prosthetics. And that is another story that has very similar themes to it. So in general, I mean, I'm excited about the potential of not just the bridge, but the potential we see in additive and in our collaborations across the board to innovate and create things that haven't been done before. And so we welcome the opportunity to work with you. We work with the ecosystem in any way, materials, software, what have you, to solve the needs that the world has and to get us to the full potential of additive manufacturing. So as we say, let's manufacture tomorrow.
Thank you very much, Jill. We really appreciated your presentation today. We do have one question for you in the Q&A, and it is actually a couple. What opportunities are there to make photopolymers more sustainable?
Yeah, that's a really good question, and we're actively working on that. I mean, I think there's multiple different dimensions you have to approach with that. One is in thinking about from the sustainability perspective of what you do with the material, with the parts after the fact, you know, how you make them recyclable. One piece we're looking at is options to take that and use that material for other applications in the future. That's the shortest term piece. The other piece is how you focus on the chemistry, and that's looking at the materials that go in and what their their sustainability impact is. For example, antimony free. We continue to look at photopolymers and how we evolve our chemistry in that regard. I think it's a far bigger challenge for sure than what we're doing in terms of the thermoplastic side, but it's something that we're investing efforts in, and our goal is like I said, by 2030 and sooner to get more applications out there and more materials out there that are sustainable.
Excellent. We have another question. It's how do you manage the approval and compliance challenge using AM?
The approval and compliance, I mean, in terms of the bridges, I assume that's what that means in terms of using AM. I think, again, I mean, I would say that each project we do is very specific. to that, right, in terms of what's required. Obviously, the two examples I shared, an infrastructure project versus a healthcare project, have very different requirements and needs. I think the key for us is in working with the ecosystem to solve those challenges as they come. We didn't talk about this here, but clearly the environmental requirements, or in healthcare, the regulatory requirements are something that the team has to work on together. And so we do that in a collaborative way. It's not one size fits all on that either, unfortunately.
Sure. How many bridges are planned and where in Rotterdam?
Well, so right now we're working on the first bridge, but I don't have the number with me, but we've mapped out with our partners and with them, with actually across the Netherlands and across Europe, we've mapped out hundreds of different potential bridges that are underway. The goal is first to get this first one in as a demonstration example. We're also working on other projects across the region, even including bridge deck projects with various governments, where we're working on beyond just a footbridge, an actual deck of a road bridge. We're working on projects around that, as well as tunnels, working on potential for sustainable tunnels projects. So stay tuned on our media, because we'll be sharing those as we come, but there's a lot of them in the works. And actually, I think the demand is, as we see these opportunities, more folks are saying, hey, we want those for our locations as well.
Excellent. Well, we are out of time. There were a few additional questions that I copy and pasted in the chat if you want to address those individually. So
Terrific.
Thank you again, Jill, for joining us today. It was a really informative presentation.